So, hello, this is Mark at Skywagons University doing another video. Today we're at Scappoose, Oregon at Sport Copter, and that's, what's the identifier?
SPB.
SPB, and we're looking at gyrocopters, gyroplanes. It's not a helicopter. A lot of you probably know that, but just to go over what that exactly is, Jim, give us the aerodynamic differences and the functional differences of the two.
A helicopter has a rotor blade that's powered all the time and a tail rotor for anti-torque, and it's flying with the thrust of the rotor system, and gyroplane has no power to the rotor blade.
So that is free spinning.
Free spinning at a back angle, and the engine is pushing it through the air.
And the engine is never driving that rotor. That's very
Correct.
important.
Only pre-rotate before takeoff, then we disengage, take off with an unpowered rotor and fly. So you could climb to 10,000 feet and shut the engine off. You can glide down and land. So passing through the air allows the rotor blade to spin.
And the thrust is from the little engine at the back,
Correct.
pushing it.
Correct.
Not a helicopter. Although it looks like one, it's more versatile than a helicopter, and it's probably the ultimate STOL aircraft that we're probably going to make a video on ever. Anyway, let's go inside and look at some of the details.
Thank you. So, as an example, here's regular glass. Pre-preg. It's an amazing product. You feel that, how flexible it is? And then here's carbon. It's more rigid, right?
Yeah, much.
Okay, but there's no backing. Now this is what glass feels like. Give it a little.
Oh damn, it's rigid.
Rigid, but here's carbon. One layer on each side. Look at that.
Solid.
Solid, right. So it's not that carbon's lighter, is you can use less of it to get the project done. So what makes that more rigid is that inside, and is a glue sheet on one side, put it down, and you put a glue sheet on the other, and you debulk that, and you put the cloth over the top. So that's how that works.
Damn, that's amazing.
But this new system, I got rid of all that procedure to be able to do this.
Oh, okay. So
And that's time consuming to do, and not as good as what I did.
yeah.
Yeah, much nicer system.
So things in the pipeline.
Yes, and then like these are test panels. We do lots of test panels. We're testing other companies' glue systems, and we do pull tests to make sure. We've had companies bring us new rolls of pre-preg, and it's just garbage. The glue system is horrible, and it just breaks. And so we find a military spec, a quality product. There's only one company I really like that does a really good job. Here's a little thicker. Feel how rigid that is? I mean, what couldn't you build out of that?
That doesn't even move at all.
Here's an armrest. Now that's got foam inside of it. I call it helicopter foam. It's a special Divinicel.
And it weighs like nothing.
Right. And it's super strong.
That's like a...
And that's what pre-preg glass looks like. Same thing. And it's one side, so you can slide it around easier. So it's just like the fiberglass you're used to, except for the resin's in it, and it's an epoxy resin, and then you vacuum it and bake it. And then we also do, we can laminate. We might take the mold and pre-prep it, and then we glue to the mold, so we can have a nice.
So like,
we sprayed it first.
Okay.
And then we bond on top of it. And then what we're testing here is cross sections. How many plies should we use in a certain area? How rigid could it be? That's just a little strip of foam. How super strong that is.
It feels like there's a bit of metal in there.
Yep. Yeah. And that's just a few layers of glass, actually, and how strong that is.
So that, from that.
It's, and then we have honeycomb in all different thicknesses. So, as an example, on the Sport Copter 2 firewall, we'll use this 1/2-inch honeycomb, and then here's thinner here. And we're kind of showing a quick,
So steel chassis and frame, and then everything else carbon fiber.
Well, yeah, you think about it. What I did was I decided to build like a quad runner because of the rough service use that they're doing. There's no way a pure composite aircraft is going to take the pounding and abuse. Look at everything else that exists out there, like a quad runner. It's got a chassis and a frame and a suspension,
Yeah.
then a structure. So I had to get really clever, a double wishbone frame to support the load and bring the tubes up a little bit. Yeah.
Yeah.
Of the M2, basically. So what they told us was, take this and make a two-seat out of it. That's what we want. Well, it's more than strong enough, but we had to go back. We have SolidWorks and some other engineering programs that we could test loads with and everything first. And then we sandbagged and did all our own testing. But we beefed up this frame a little bit more in certain areas.
This is the one that's popular with the Australian
very
sheep
popular.
mustering.
Yes,
cattle
yeah,
mustering.
Yeah. And so we've got several hundred of these machines out, and this airframe stood the test of time really well. And I designed this in my 20s. This very first, the Lightning and the Vortex, this is based off of that.
So talk about what you were saying about the suspension and the mast suspension.
Right. So these are steel plates. These are urethane bushings in here, and what we're trying to do is isolate the nodes of frequency. So the nodes of frequency of the 2 bump per rev in the rotor system is moving, so this mast can pump up and down, and it can orbit. And the
the shock in the air.
Shock in the air.
And on the ground.
On the ground, both. You want to save that rotor system, and you want to save your airframe. And the majority of my competitors are cracking somewhere in the frame, or they're pushing in that area on the engine. We've beefed this up with 2 tubes of 4130, welding them together, in which you get a much more robust structure. And also, we have bushings everywhere bolts go for tightening things down. It's all sealed. We can purge that too if we want to, if a customer wants that. Linseed oil and purge it like an aerobatic airplane for cracks. And you can put a little pressure gauge on it or vacuum gauge on it if need be.
And then this, not only is it the suspension, that allows you to fold the mast.
Correct. So you can pull this fastener here, and then the mast folds back, and we got a little stand on the engine mount. And then you can be in a really low height storage, normal garage. It'll fit these big tires. It'll fit in a standard Wells cargo trailer. So you can roll this in a little Wells cargo and go somewhere and have a portable aircraft. It's pretty cool.
How quickly can it be like flying the moment when you roll it out of there?
If you're just putting around, it might take you like 6 minutes to raise this mast up.
That's nothing.
And you're sliding 1 bolt in here, and you're attaching these 2. So you got 3 fasteners, then 1 bolt for the rotor system.
1 for each blade.
And then the blade is 4 bolts on each side of the hub bar, but usually you leave the hub bar on one side. So field expedience is quick to get the machine in the air.
So is this able to be, I don't want to push on anything, can you make it suspension actuate?
Well, there's no engine on it. I might be able to get some stroke out of it. See, it's really stout because there's no engine.
It's not heavy at all.
We'll take this one over here and we'll move it back and forth.
That weighs nothing, right?
Yeah. There's not enough weight on it to actuate that yet.
And they go with bigger tires, much bigger tires?
Yeah, absolutely, yes.
That makes it a very off-road, short field.
Yeah, so the suspension gives you both your long-lasting frame, but you could be at 5 feet and flare and let the machine drop into the ground, and that suspension would stroke and then protect the aircraft. And then with the castering nose wheel, so it swings to the direction. So if you're coming into land and you're crooked, like even 20 degrees, when you hit, the gear strokes shoves in, absorbs that hit, and then gives time for the nose to swing around straight. You can just sit there. I got videos showing this, where I cross up, hit, and the machine just straightens out. So, typical gyros out there, you have to be careful where the nose is at. That's too much workload. So you're taxiing the aircraft, you get going, you don't want the nose to come up until you're ready. They want the nose on the ground. Well, that doesn't give you
airports.
That doesn't give you the proper angle for a quick takeoff. So one of the reasons we take off so short, we don't have to worry about the nose wheel being up or down. And we don't have to worry about where the rudders are. I can correct for crosswind, the nose can come up, the nose can come down, the nose doesn't turn. A lot of my competitors connect it directly. There's no connection between the nose and there.
Just completely
the
free.
Wash from the tail pushes the front end around on your run. At slow speed, the differential braking can pivot steer the aircraft. So for safety reasons, you got a spinning rotor around an airport and people, it's nice to be able to maneuver around airplanes and things. And if you're on rough ground, you can taxi into position a lot easier by pivot steering the aircraft, getting it ready to go. And then on launch, on takeoff, you just rudder normally like you would if you were in the air and never worry about the nose turning. If that nose turns, you have to be conscious of it cocked to one side, and if it touches back down, you can ground loop like that. And the majority of the fleet of gyros out there, that's what happens to them.
So that will automatically compensate for
Automatically compensates, which gives you...
And if it wants to lean and potentially tip, the suspension will take care of it.
The suspension takes care of it on the hit, that spike.
Yeah.
It doesn't grab. So the mass wants to continue one direction. So when the aircraft hits, the nose swings around automatically. You don't touch it. And the machine just straightens out by itself.
Excellent. Yeah, so it's nice to see one naked.
Yes. We could look at the M2 now. Walk around.
So Jim, this doesn't look much like a Rotax.
No, it's not. It's the Aero Momentum. They call it the AM15. So it's a little car engine converted for aircraft use. And a lot of folks are using them. And we have some clients that are interested in this. So we developed an engine mount, and we're doing the pre-rotator system to allow for a more inexpensive engine, approximately the same thrust. Weight to power ratio, it might be a little bit better than the 915. We're going to find out.
What's its cubic cc's? What's the?
It's about 146 horsepower is what they're calling it out at. Off the top of my head, I don't know. It's approximately about the same displacement as the 915.
Okay.
And it's got the big brakes on it, just like the other machines. You know, same tail boom, everything is the same as the 915 powered machine. It's just a different engine mount, basically, is what we're going for here. And on this, you can see this is another one going together. That's the prototype over there. This is a second machine, and we want to test a couple of engines. We have an additional engine we're looking at using too, a General Motors product, and it's really nice. And it might be closer to 180 horsepower.
Oh, really?
Yes.
What are the prop RPMs of these non-geared? That's the pre-rotator.
No. This is the propeller drive right here.
So that's geared.
And you're gearing it down, right?
Okay.
And so propeller RPM is similar to that of an airplane. You know, the 2750-ish peak RPM or less.
And the engine's what, 3,500, 4,000?
No, they're pushing it up over 5,000.
Oh, are they?
Yeah, that's how you get the power out of it. It's the only way. Either you're going to go big pistons like a Lycoming or a radial engine.
Oh, yeah.
You know, or
spin it.
Or you have to rev it up like you would a race bike.
Normally aspirated, injected, non-turbo. What's the?
This one's non-turbo, but the 915 is turbocharged and injected.
Okay.
And you know, the plan is this other engine we're looking at. It's injected and turbocharged.
Excellent.
Yeah.
So what will that be on, a four-seater?
The other engine? No, this one right here.
The big one will do a four-seater.
Oh yeah. The big one. I have other plans. It'll be hydrogen electric.
Really?
That's where the whole industry is going to go. The whole world will go there. It'll be hydrogen electric. Mark my words.
That is actually very interesting.
Yeah, it'll be hydrogen, and the best system will be you will put water on board the aircraft.
I've done crack it.
Yes, I can make bubbles as big as my thumb in this reactor that I built. And so I'm already looking at the energy source is the problem. Tesla's new batteries they're going to produce would be a good buffer, but the best concentration of energy is going to be pure water on board, the safest way to fly, versus liquid hydrogen.
Yeah.
And we already know the drones are flying for 5 hours on a tank of liquid hydrogen. That's an amazing feat.
Water is two very highly combustible gases, oxygen and hydrogen.
Yep.
So you just got to split them up and burn them.
You got to do it efficiently.
Yeah.
And there is a system that's very efficient. I mean, that's how Apollo went to the moon and back on hydrogen fuel cell. So the new fuel cells, I believe, is going to be the safest thing for aviation.
And the exhaust, it's water?
Right. There's nothing. It's clean.
Yeah. That's interesting. A lot going on in the future of
when I designed the machine, I looked at it from the standpoint of being electric. So we can put different engines on this platform. So this airframe really gives me a lot of room to do lots of things. We even shock mounted the firewall. See, that's in urethane right there. So the mass can wiggle and give a little bit to help it fly smoother. Things last longer. I found that by urethane mounting parts of the aircraft on an impact, it doesn't come apart. It gives it that stroke and that time to keep the airframe together. Because it's not if the engine quits or your power quits, it's when. And then if you have to put it down somewhere because you're flying this thing low and slow, and you're putting yourself in danger, the aircraft should be able to absorb an impact and protect you. And that's what we designed into the whole airframe, the whole aircraft. Is everywhere is they have a stroking zone or a crumple zone somewhere in the aircraft.
So can you tell us about the seats that you recently tested and the G's that they can experience?
Yeah. It was in '09, but we were at MGA Labs, and we were absorbing 300 G. 2 hits at 300. And you see how fast the lab technicians grabbed the phone to the general. It was pretty cool. And then we took those guys out to dinner to find all the secrets with what's going on. So, yeah. But, yeah.
So this is an M912. Jim, go over some of the details that make this what it is and why it's so popular.
Okay. Well, first of all, obviously, your eyes are drawn right to the suspension. So this has got about 10, 12 inches of stroke. And donuts here to bottom out on, which it doesn't. It can take pretty good hits. So you could be at 5 feet, completely below the landing, and make it look really good, and just tap the ground with it. It's really nice. Of course, then on your takeoff run, it gives you a lot of great stability, and tracking on the ground to get that short takeoff on rough ground, where a typical machine wouldn't be able to do it as well. Rough bouncing doesn't allow the rotor system to wind up as well. And then, of course, as you move up the mast here, it's all 4130 welded mast, and then we have the suspension system like we talked about before, and that allows this whole mast to give and move. And then, of course, the mast folds. They pull this bolt, and it pivots here and comes back, and off of this bolt we have a tube that goes here that allows it to be bolted and to hang on to it. There's a bracket that goes on there. And now you can transport the aircraft. Of course, the blades come off. Mast folds back.
Which is the single bolt you said removed?
At the top right there, the teeter bolt. That's removed right there.
And the whole thing comes off in one
Yep,
go.
yeah, one thing, it lifts right off, then you can fold the mast back, and we just pull this bolt, and pivot on this one, and that comes out. Typically, we have a safety pin here, but because this machine, this customer, chooses to have it hangered and flying, without folding ever, it's set up that way. Typically, if we have safety pins everywhere, you would want to fold really quick, so you don't have to pull any cotter pins. But
so what's the performance on this, like the takeoff roll and landing in calm air and that kind of thing?
On a standard day, standard position, like near sea level, no breeze, you could be like 20 feet. You can spin over flight speed, so we can spin to 300 RPM on this. And the M2, I've achieved 350.
On the pre-spin?
Pre-spin. Well, that allows then a super short takeoff because this rotor blade is designed to fly at 275.
Oh, okay.
So when you speed up, it's going to slow down a little bit in the run. So that allows us the time to get into the air really short. I mean, maybe a 4-mile-an-hour breeze, you can be in the air in 10 feet. And you can climb at 20 miles an hour in this machine, at 20 to 50 of its climb range. So you have to be a real numbskull not to be able to manage but stay between 20 and 50.
Yeah. And then, now, when such a short takeoff roll, if you can find a 20-foot area that doesn't have rocks in it, that isn't too rough.
Yeah, you need clearing, ahead of it. But yeah, you can get in and out of a very short space. Now we can compete with STOL airplanes, big time. I can crush them on a landing.
Because landing, it'll nearly spot land.
I can stop it. And that's what's interesting. With the suspension, now you can cheat. Rather than gliding in and tickling the gear, you can give a little pop on the stick and stop the aircraft in the air and let it drop right onto the gear, no roll. And that's beneficial on really rocky ground.
So 0 in, 20 out.
Yep.
In length.
Yep. At 20 miles an hour on this machine, standard day, 200-pound pilot, fuel, you're looking at maybe 100 feet a minute. And then at the proper climb speed, which is closer to 40, you can see 1,000 feet a minute. Turbocharged, if you were to get one of these special engines that they do overseas, you're looking at like 10 feet. You're in the air. I got a video. It's called Superman. It's a turbocharged engine. And at 20, it's 500 feet a minute. And at 40, you're like 1,500 feet.
Excellent.
It's amazing is what it is. Absolutely amazing. But I don't recommend running those engines that hard, but that if someone wants it, it's available. You know, to really
it's capable of doing it. It's always nice to have something more capable.
Yeah, and then you feel comfortable doing that in a machine like this because you can blow the landing, be in trouble and be down low zooming around because if you have to tap the ground on a rough surface, the suspension will handle it. And the nose wheel, what's unique about this is that it casters, straightens you out, you're not connected anymore, and so that's more rugged to take that. The nose wheel has suspension too, and you can be in and out of really rough areas and have a lot more confidence to do it, where normally a lot of these airframes won't take it. There's a lot of machines that are put out there that require that you do not pitch over 40 or bank over 60. I can loop and roll this, and it's an aerobatic aircraft. I'm selling it that way. Do I recommend you do aerobatics? No, but you can be at 100 miles an hour, slap the stick to one side and pull back on it, and at 100%, this suspension system in the mast and the whole machine can take those loads.
It's nice to know it can do more than you can.
So when I first built this and started flying it, I realized really quick it was beyond my ability, what I could do. Right. And then that's when I really started pushing this thing and started doing loops and rolls, and I was just having so much fun with it that, you know, it felt like I had my hands on a Hughes 500 or something like that.
But never unload it.
I actually teach that. One of the maneuvers that I do, we can bunt and recover. I actually do that in the trainer as part of the advanced training. Or we side slip and starve the rotor and then correct it again. And you win your wings with that when we go up and do bunts and slips. Yeah, and we do tail slides and chandelles and different things like that. Just no loops or rolls. That's going to come later. Right. You got to wear a parachute for that. But actually, that advanced training is kind of like stall training. Right. So when you get all your training and you're all done, what does it feel like to unload the blades? It's not death, but it's important you have a large horizontal stabilizer because when you pitch the machine over, if you don't have enough surface in the back, it'll want to continue to tuck. But with it being balanced, then it stays straight and recovers.
Yeah. Interesting. Very interesting. Let's go over a look at the big brother. Yeah, so this is the M2. This is the new model, 2 seats. Jim, tell us about this one.
Okay, it's based on the M912's airframe, but a beefed up airframe. So because we have all the tooling, all the jigging, and the airframe is so robust, the core of this machine, like a quad runner or a motorcycle, it's got a nice airframe to absorb the impact, the crumple zone, the long life that you inspect. And then we've added a carbon fiber shell, but it's beefed up. In here, all the way around from here like this, it's like a hoop of steel.
So these are the 2 halves of the mold.
Correct, these are the 2 halves, and these 2 hoops right here are tied directly into this firewall, which is then bolted directly to the mast and the urethane mount here, and then it goes all the way around like that. So this really creates an amazing, strong structure. These are foam core with the unidirectional fibers inside of here and the carbon over the top. So it's a big chunk like this, tubular shape of carbon fiber that gives us the strength. And then we have little ribs of carbon in here also. And the headlight bucket is easily replaceable. When you film that, you'll see that, how we can get to the headlights really easy. And it's a really lightweight carbon fiber container that actually vents. And it's adjustable. There's little adjustment screws for the positioning. This is all CNC'd, all these pieces. All the tooling here was all CNC'd, drawn in SolidWorks, the whole aircraft.
Does this, the aerodynamics of it, does it help with cruise speed or anything?
We wanted a shape that was different, and the purpose behind the design was a flat wrap windshield versus an acrylic.
Oh yeah.
So this is
it's not a bubble.
This is like I can replace this for $100 versus an acrylic window. It'd be like $1,500 for one side on the SC2. It's really expensive, and this is more inexpensive and easier for the customer to reinstall. So this windshield then is just bolted in, a flat piece. So you could remove this, lay it on a table, cut out a new shape, put a new one in, and replace it yourself. You don't have to come to us to do that. Now we did blow these and this is all Lexan, this is Lexan, that's Lexan. the nature of what we're doing is we're low and slow zooming around. If we roll over, you know, hit and roll over, you don't want the windshield to crack and become, you know, a bad sharp edges. The acrylic does that. This doesn't. I mean, you can, you know, beat on this thing and it's not a big deal, okay?
Yeah.
So it really takes a whopping, you know, the whole thing.
And that movement and all the vibration over time and use, you won't be getting cracks.
No. You drill over. The secret is you drill oversized. We got a good seal here, and it's not an issue. It's not the hard plastic. It's a different plastic. This does require more, you know, tender loving care, a polish, a plexi polish like for a motorcycle windshield, but it's longer lasting and cheaper to replace. If you don't like it, put a new one in. So to get a fast takeoff, this is what we're supposed to do in a gyro, not some airplane takeoff. Why should a gyro fly like an airplane, eat up the runway? Well, why? One of the reasons we don't is how the controls manipulate. So the rotor brake is right here. You lift it up and you release it and it disengages. You pull it up like this, you push that down, it locks it. But what if you forget? So internally we have a release system. So when I grab this is the throttle right here, and you can see the other side's working too. Okay, so for the instructor and the student, the throttles are connected, and the pre-rotator's connected. See it move?
Yeah.
But let's say you forget. When I pull this up, it disengages, and then you can pull back like this, lock. So you're slipping the belt is what you're doing. You lock, a little bit more lock, a little bit more lock. Then you rev up like that. You got the toe brakes on. I call it the carrier launch. You're revving up, revving up, revving up, revving up. You pull this back, let go, take off. And that time, how fast that is, and because we have a flexible shaft, we don't have to hold the blades level. I can have the stick back, spin up, and do that maneuver, and that's why I get in the air so fast. One of the reasons.
How many hours have you got in gyrocopters?
Approaching 4,000 in just gyro.
And if somebody were to learn from like being a private pilot, single engine land, to flying one of these, what's involved?
About 7 hours to get comfortable, especially if you're a tail dragger pilot. You have more feet.
Yeah.
So that's the difference. Rotorcraft, you require more ruddering. Like a tail dragger, you require more ruddering. Once you understand what it's doing and how it works, it's easier to fly than an airplane because it's very forgiving. It doesn't stall.
Right.
So you can slow way down, get way behind the power curve, and recover again, which you don't do that in an airplane.
And you can turn on a dime. And
we can turn around, right? We can do like a canyon turn. You're going up and just pull back on the stick and stuff the rudder and turn around and go the other way. Yeah. So things like that make it a lot safer to maneuver and fly. And then we took the control stick and have a single with a double Y like this, and I have a parallelogram in here. And and we have an air trim system, so I can actually move the control stick with air pressure. See how it moves? Now when it's flying, it's completely different than when it's on the ground. If I push this little trim here, it takes off over to the one side, comes back the other way. Purpose is obvious. At any speed we can trim the aircraft. But one of their requirements was that we can get in and out of the aircraft and take somebody on board. Well, what's nice is there's no stick to step over. And this is very intuitive to operate. So a ranch hand can hop in and get out again while the rotors are turning, while the engine's running, and not worry about stumbling over the control stick. Yeah, you bring it. Right. You can trim it all the way forward like this, let go of it. The trim system holds the stick forward for gusts, and you can get in and out of the aircraft. The pilot, of course, should be, proper procedure is in and out the front, but it allows a safer cockpit environment to, have your storage. You have a little bag right here. You have your stuff. You can, there's room under the seat to stuff things. We're going to have cargo pods here too. There'll be a step right here. People can get in and out of it quickly. Filming out of it. It's nice not to have anything in the way. A control stick. You don't have to remove the control stick. And if someone wants to take over and fly a little bit, they can still do it. I didn't think I would like this, but I love it. I flew a side stick one time and I went, that's fantastic. And I thought, well, I got to do something that's more intuitive for the average person to fly. And it's nice is you can put your hand here, you can hold it in the middle, hold it down there. It's very comfortable to operate.
Could you shoot coyotes out of it?
You could, yeah, you could.
It's very versatile. It's the perfect ranch machine.
Yeah, it's a ranch machine, yeah. This has got the Conforfoam cushions everywhere in here. Now we're using Cordura, but you can go to leather too if you want to. We're using inertia reels in here, but we can go to 4 points or 5 point restraint, not a problem. There'll be a little cover on this area here. We do these, few little things, it's kind of cool.
Trim in detail.
Yeah, and then
is that a door handle?
Correct. So the doors are going to bubble way out like this. And the purpose of the cockpit being narrow is obvious. We're trying to make it more like a single place when you're solo, and then you're going to carry a passenger a jump seat. That's the idea. And when you put wheel pants on it, and then the mast fairing, and we clean it up, then it'll be more of a gentleman's machine for cross country. But we want a workhorse too. No one builds a tractor for gyros. So that's what this is. Doors off. They want it out in the open. They want to be able to zoom it around and have a single place feel. And being narrower like this, it makes it more nimble.
Compared to a helicopter, a light helicopter, how is it for one person sitting on one side in a gyro like this?
I don't have any imbalance issues. I don't have to add a weight on either side.
Okay. Well,
yeah, I can fly it. The rotor head's offset to one side to counteract the torque. So when I lift off, even on this seat on the wrong side, it doesn't matter. I don't have to worry about lateral stability at all.
So is solo from the left?
Yes.
Yeah.
Yeah. You could solo from either seat in this machine. Yeah.
Depends on where you're comfortable, throttle or stick.
Yeah, and we can rotate propeller either way, and the rotor head can be built either direction. Yeah, so it's versatile in that respect. We designed it. There's reverse parts that make the rotor head offset the opposite side, and we can run it either way.
Did you say you can turn the propeller the other way?
Not this propeller, but say you put another engine on, and the propeller's going to go the other direction. That's the whole purpose of the design. What if we run a different engine and it's reverse direction? So the machine will, depending on how it's ordered, we can run the trim opposite on the tail, and we can run the rotor head the opposite way, and we can then, of course the gearbox, pre-rotator drive has to be proper, but we can run it either direction.
Very interesting.
Now these scoops aren't just for looks. What's happening here is this intake pulls in, helps pull in air, so I'm sucking the air against the body more.
So that air is passing behind, sucking it in.
To hold it to get to the prop cleaner, because I'm breaking it away really fast. So these are like...
That's just drag though, this is cooling.
Correct.
Yeah.
Well, that helps cooling going through. Yeah, the fans are there for cooling, but I'm pulling air through there because the intercooler is in here too.
Oh, because it's turbocharged.
Oh, jeez. Okay, so the rudder pedals adjust whatever you'd like and lock in place, and it's really nice during a long flight, so you can quickly adjust it. And it's got the toe brakes, differential braking, all in one unit, and very comfortable and easy to operate. Now I'll tell you something very unique about the machine. If you look here in the back, my competitor, I forgot about this. See how that has a ball end on it, just like aviation, ball end? So you remove those two bolts, and then this cable then can feed all the way back through, and you can inspect your cable. My competition, they have a thimble on there, and you have to cut the cable and throw it away and start with fresh. And with this, it's serviceable every annual. You can just pull it through and inspect the cable, pull it back through. So there's a Teflon liner in there that it rides on, and then pulleys up inside.
How do you get it back once it's gone?
You just feed it through.
Oh, it just feeds?
Yeah, you just feed it through. Yeah, very simple. And then you got turnbuckles to tighten it up, and you're all set to go. Versus cutting them, throwing them in the garbage, or you can't inspect them, and that's not good. So you want to be able to, every year, annually inspect those cables, or on a moment's notice, inspect it.
Is that something that frays and wears?
Yeah, it can. All gyros, on all aircraft.
Yeah.
But to have to cut the cables and replace them, that means it's going to be maintenance that isn't proper, because someone's not going to want to do it because they're not going to want to cut that to inspect it.
Right.
Here, we can randomly inspect the cables anytime, and this system allows us to do it. And not being a horn, it's the same leverage the whole way. So this round and that round are identical.
So the pull is even.
So the geometry is perfect.
Right.
And then the mixer connects into the two rudder pedals. And it's just like any jet airplane, how it's done.
Yeah, advanced engineering, excellent.
Yeah.
So Jim, thanks. That was very comprehensive. We'll come back another time and fly one.
Yes.
An incredibly interesting machine. Thanks very much.
You're very welcome.
This is Mark at Skywagons University. Subscribe on the link below and click on the little notification bell if you want further videos. Thanks very much.
Can you say I love you? I love you. Kona.
Oh, he's such a good boy.
All right, let's see if he does it.
Did you get
I
it?
don't have any bites. Say I love you. I love you. Come on. Talk to Dad. I love you. I love you. Okay, give me a nose bump. Okay.